Welcome to the Walton Pi. Today we're going to be talking about integration by parts. So integration by parts is a method of integration that has its origins in the product rule. So if we remember about the product rule, the derivative of f times g is f times g prime plus f prime times g. So that means if we were to take the integral of f of x times g prime of x plus f prime of x g of x, we would get f of x g of x, because integration is the inverse of taking a derivative. So that means if we were to rearrange that equation, that's how we are able to find our formula for integration by parts. So if we take the derivative of f of x times g of x, that gives us f of x g prime of x plus f prime of x g of x. And if we were to then integrate both sides of this expression, we would get the integral of the derivative of f times g is equal to the integral of f times g prime plus f prime times g. So the integral of the derivative, that's just f times g. And so what we end up with is f times g is equal to the integral of f times g prime plus the integral of g times f prime. And so if we were to subtract the g times f prime to the other side, we get an equation that f times g prime inside an integral is equal to f times g minus the integral of g times f prime. So let's summarize this in a easier to remember form than this. This is just the reasoning behind why it works. So the rule for integration by parts is the integral of u dv is equal to u times v minus the integral of v du. So u dv becomes uv minus the integral of v du. So, for example, if we were asked to integrate x e to the 2x, well, we can write this as the integral of u dv, and if we can do that, then it's going to just be equal to uv minus the integral of v du. So in this case, we have to decide what do we want to be u and what's going to be dv. So if we make u equal to x and dv be e to the 2x dx, then that tells us that du is just dx, and v is going to be e to the 2x over 2. So we can then plug those into our form uv minus the integral of v du. So that gives us x times e to the 2x over 2 minus the integral of e to the 2x over 2 times dx, which is x e to the 2x over 2 minus 1/2 e to the 2x over 2, which can be rewritten as 2x e to the 2x minus e to the 2x all over 4 plus c. That's how we can use integration by parts in this example. Now, there's a few different tips and tricks that we can remember when doing integration by parts to get a good idea of what to guess for our u and our dv. Because here, I just picked u to be x and dv to be e to the 2x dx, but we could have chosen dv to be x dx and u to be e to the 2x. So the question is, how do we choose what we want to be u and what we want to be v? So first, derivatives are in general a lot easier to compute than the integral. So if we are stuck, we would like to pick dv to be the thing that is easy to integrate. Because we could take the derivative of a lot of functions, but there's very few types of functions that we know how to integrate very easily. So if one of the pieces is something you don't know how to integrate, then don't make that be your dv. Make that be the u. Second, sometimes we might have to do integration by parts several times before we're able to integrate it directly. So don't worry about this, just repeat the process as many times as you would need to. Sometimes our original integral will show up again in the integration by parts. If that happens, you can then try and solve for that integral by rearranging the expression. This often happens if you have like an exponential times a trig function. That is where this situation normally will come up. And then last, you almost never want to pick a polynomial to be dv. So in our example of x times e to the 2x, x is a polynomial, so we almost never want that to be dv. The only time that we would want that to be dv in general is if our integral has a natural log or a logarithm showing up as well, then we would want to make the polynomial be the dv. But other than that, we are going to want to usually make our polynomial be the u. I hope this video was helpful. Please check out my next video where I will be going through several examples of integration by parts and going through each step so that we can be able to get a lot of practice together on doing them. Please like and subscribe if you haven't already, and please check out some of my other videos. Have a great day and good luck with the rest of your math.